Hello everyone. Welcome to this session and we are discussing about manufacturing of different automotive components, and this is session 3, and today we are going to discuss some more automobile components manufacturing methods such as crankshaft, camshaft, and we are also going to discuss about manufacturing of engine block, engine cylinder and cylinder liners. So let us start this session. So as you know that crankshaft and camshaft are very important components in IC engines. The manufacturing of these components is very critical, and these components has to have a great and good endurability, reliability, accuracy and performance. So camshafts are responsible for opening and closing of engine valves at correct timings so that we can supply inlet air or inlet mixture into the cylinder, and at the same time we can exhaust the gases once the combustion is completed. And similarly the crankshaft, we use it for converting the rotary motion into reciprocating motion or vice versa. But here in IC engines we are going to convert reciprocating movement into rotary motion. And typically these are the camshaft and crankshafts are typically manufactured from forged steels and cast iron materials. So let us start with different manufacturing methods. So mostly these crankshaft and crankshafts are manufactured with casting methods or casting process, and then the most next process is used forging. After forging and casting process, these components, that is crankshaft and camshaft, must undergo machining process to get the required dimensions and surface finish, and then to improve the properties, that is properties of the mechanical properties, we undergo that means these components undergo surface hardening methods. So casting. So in a casting is in a process where the molten metal is poured into the die and where it is solidified, and then after solidification, if you extract the component from the mold, then we'll get the component. So there are different methods we use it to manufacture the crankshaft and camshaft. So the most precise method is investment casting. So here this method is also known as low wash casting process, where wax as a pattern to produce the precision parts with high accuracy, and this is we use, that is investment casting, we use it for only small size components or a small size crankshaft or camshaft. If you want a larger size and high volume products, then we go for die casting, where the die is made with the metal, and here again the process is same, where we in the die we pour the molten metal and then we allow for solidification. After solidification we extract the component, and here we get good surface finish. And the next manufacturing method is centrifugal casting. So here because the crankshaft and camshaft, the nature of these two components are having the axisymmetric, mostly in the cylindrical shapes, so that's why we can also use centrifugal casting. So where we can produce the spinning of the mold to produce the symmetrical parts such as crankshaft, and here we use permanent molding castings, which uses reusable metal molds to produce the high quality parts with excellent surface finish. Along with that, we can also use shell molding cast process and vacuum casting, also used to manufacture the crankshaft and camshaft. So you can see here, this picture shows the die casting. So these are the two dies, one is the lower die and upper die, and here we pour the molten metal. After solidification we extract the camshaft. And the next method mostly used is forging. So forging, where the heated billet is placed between two dies, and then we apply the forces so that we get the desired shape. So this process is used for producing high strength, more durable and complex parts such as crankshaft and camshaft. So there are various processes are involved. So mostly we use closed die forging process. So here we use precision die to produce the parts with complex geometries. And then next to the closed die forging, we use a drop forging also. In the drop forging, we use hammers or press to get the shape. And the next one, we use press forging, where we use hydraulic fluids to get the required pressure or force on the dies so that we get the required shape. And the last one is rotary forging, but very rarely we use this forging process to get the camshaft and crankshaft. So here you can see the another picture. So this is a raw material. We take it in the billet form, that is a square cross section, and then we apply the forces on this material after heating the material, and we place in the dies. So in the progressively we get from the stage 1, stage 2, stage 3 and stage 4. So finally we are going to get the required shape after removing the flash from the material or initial steps. So these are the steps involved in making of the camshaft. After casting and forging, almost every component must undergo the machining process to remove the excess material to get the required dimensions and the surface finish. So mostly we use turning process, milling process and the drilling process to get the required dimensions and shape. That means final finishing of camshaft and crankshaft. Sometime the same component, that is crankshaft or camshaft, initially it will undergo the turning process, that is lathe, and then the same component undergo for milling process, where critical areas to be machined, and then wherever the holes are required on the camshaft and crankshaft, we use drilling machines to make the holes on the shafts. So we can go for, after machining or primary machining process, we go for grinding process to further finishing of the component. And nowadays we are also using CNC machines to make it more quick and good surface finish. And then additionally we go for broaching process, further finishing of the or final finishing of the camshaft and crankshaft. And this is the camshaft, you can see here, and this is being machining on a CNC lathe machine. And the next process after machining on the crank and camshafts are surface hardening. So this name itself is, you can see, hardening process. So after manufacturing the camshaft and crankshaft, it's supposed to undergo hardening process to improve the hardness and wear resistance, fatigue strength and the corrosion resistance. So for that we use different processes. For hardening processes or a hardening process, we use flame hardening, where high temperature flame to heat the surface and then we cool it to room temperature so that we'll get required hardness. Along with the surface hardening, we also go for induction hardening process, where the surfaces are heated with the electromagnetic induction to heat the surface, and then we cool to get the required properties. Along with that, we also use laser hardening process, where high energy laser beam is used to heat the surface so that we get the required strength to the camshaft and crankshaft. After that, we also go for nitrating process and carburizing process. Nitrating process means where we induce the nitrogen gas onto the surfaces so that nitrogen layer will form on this surface so that the surface will get hard as well as wear resistance. And the next surface hardening process is carburizing process. Here we diffuse the carbon element. We diffuse the carbon element onto the surface of the crank or a crankshaft, so that we are going to improve the hardness as well as wear resistance of the component. So along with that, we also combined both carburizing and nitrizing process, so that we call as a carbonitrading process, so that we get the combined effect on the component. So along with that, sometimes we also use boriding process to improve the surface characteristics such as hardness, wear resistance, etc. So after some of the engine components, now we are going to discuss how the engine block is going to manufacture. So the most of the times we use casting process, that too sand casting process. If not sand casting, we go for die casting process, so that we get precise engine block. So for that, you can see there is a systematic flow chart is there. First we have to make pattern making, and then with the help of the patterns we are going to make the mold. After molding, we are going to pour the molten metal, and we allow for solidification with the help of the cooling process, and then we shake out or clean it, so that we are going to get the engine block. After getting the engine block, we go for machining process to get the required surface finish. So this is a schematic diagram or a schematic view of an engine block which is produced from the casting and then machining process. So those are the steps we already discussed. And the materials used for making of engine blocks are grey cast iron, graphite cast iron, aluminium and magnesium alloys. After engine block, the next important part in a IC engine is engine cylinder or cylinder liner. So these cylinder liners are manufactured with centrifugal casting process. So first, after producing the cylinder liners with the centrifugal casting, we go for rough machining with the help of facing and outer turning process and inner boring process, and final finishing we done with honing process. And the materials used for manufacturing of cylinder liner is cast iron, and these are the examples for the cylinder liners which are going to use in IC engines. And the next important component is cylinder head. So the cylinder head is placed on the top of the engine, and this part is also manufactured with casting process mostly, and very rarely we use forging process. So here casting process which we are going to use is die casting process. If not, we are going to use sand casting, but the die casting process will give good surface finish and good mechanical properties, whereas a sand casting process further finishing process is required. Whereas in a forging process, mostly we are going to use drop forging process, and here in the drop forging process we get good strength to the component. So these are the steps involved in making of engine head, and this is a block diagram or a flow process of making the engine cylinder head. So first we will take blocks, blank material or raw material, and then we go for milling process, then we go for finish milling process, drilling of auxiliary holes, finishing of milling bottom surface, and then we go for processing of guiding holes processing, and then we go for drilling of exhaust valve seating hole. And then after making all these engine block, then we go for leakage test, and then the component will be dispatched to the stores. The next one is manufacturing of disc brake and holder. So you can see here, this is a disc brake, one type of variety, and this is another variety of the disc brake, and this is disc brake holder. And these two components we manufacture with the two different manufacturing methods. First, let us discuss the disc brake. In the disc brake, first, mostly we use casting process. We prepare the molten metal. After preparing the molten metal, we pour the molten metal into the die casting, that is hard chamber die casting process, and then we finish with the turning process. Then we go for quality control, that is dimensional checking. Once it is quality check is passed, we dispatch to the stores. So that is the sequence of steps for manufacturing of disc brake. And then we discuss the holder. This is a holder shape to hold or to clamp the disc brake to the holder. And here also almost similar process. We first prepare the molten metal, and then the molten metal is poured into the die casting. But here we use cold chamber cold chamber process, and then it will undergo, after making the holder, the component undergo the heat treatment process to improve the properties, and then as usual surface finishing process, quality check and dispatch. Here the disc brake is manufactured with grey caster material and the holder is manufactured with aluminum material. And the next component is drum brake. So the drum brake, mostly we use spheroidal grey cast iron material, and it is having high strength, ductility, and it can able to withstand the shock resistance and wear resistance. And mostly we use casting as a process to make the brake drum, especially shell casting or sand casting process we use it. After making the brake drum using these two processes, this component undergo the machining process to improve the dimensions, surface finish, and ensure the proper fitting. After that, the same component undergoes the heat treatment to improve the wear resistance and reduce the internal stresses. And this is the schematic view of disc brake. Okay, so that's all for this session. So today in this session we have discussed the various engine components manufacturing methods, such as crankshaft, camshaft, engine block, engine cylinder, drum brake, disc brake, etc. Thank you.
Like, share, comment, and subscribe VNR Digital Learning Resource YouTube channel.